Welcome to the Reliability U podcast with Brett Scott and Adam Lunt, where we talk about all things reliability. Stay tuned. Well, welcome back to the Reliability U podcast, where we have been plagued with technical difficulties all evening. But we're here now, so please sit back, enjoy, and let's learn about reliability together. I'm your co-host, Adam Lunt. With me,
Brett. How you guys doing?
Brett, thanks for taking the time out tonight to fight through these problems with me. I think we're finally making some headway.
By the way, cheers.
Cheers. Like that clink, we're sitting right next to one another, and you'd never know it.
For once, this is actually happening.
Yeah, it's rare Brett and I both get out of the field and back in the office on the same day, but we managed to do it this week. We were able to spend a little bit of time this week going out, working on reliability use stuff, as far as getting some swag ordered. We got some T-shirts coming, some hats coming, stickers. We also made a stop this week out at go meet up with our good buddy Brandon T out at LFG Barbecue and Outdoor Store down here in Ottumwa, Iowa. He gave us a hell of a hookup on some Yeti whiskey tumblers. Technically water bottles, but you put whatever the hell you want in them. So we're getting those branded with the reliability use stuff, and we're going to get those. We'll have those available as well. Want to start, offering some nice parting gifts, if you want to call it that, to the people that are gracious enough to give us their time to come on the podcast. So yeah, that's kind of what we've been up to as far as reliability use concerned. Brett, what have you been up to just in life?
So traveling, of course, last couple weeks. That, of course, you and I both do that a lot, but finally got off the road for a couple weeks back home, which just means catching up on emails and other things that need done, and then also all the homework that needs done. As you know, I've got an outdoor wood boiler that heats my house, so I cut firewood, and there's a tree that went down across the road, just huge tree. I can barely get my chainsaw through it. But so, and saying that, that's why I am sore right now. I've been chainsawing all weekend, and I'm not as young as I used to be. So,
I think that's probably true. I mean, that's just basic math, isn't it? Who was it? Mitch Hedberg that once did that thing. He's like, "Hey, you want to see a picture of me when I was younger?" And he's like, "Well, I'd love to see a picture of you when you were older."
Yeah.
He's like, "What kind of magic camera do you got there?"
Yeah, it was class.
That guy was amazing. Yeah, so the same. It's like this is always kind of a slow time of year for us, which I'm totally cool with. It kind of gives you some time to get caught up, like you were saying, house stuff and blah, blah, blah. I know next week, Mario Rostron and I from Ludeca are going down to Kansas City. We've got a 2-day event down there. It's a best practices seminar down at the Kansas City Convention Center. Fortunate enough, actually, we have Paul Crocker coming over to join us there. Got him a badge, so he's going to come in because Paul knows everybody in Kansas City when it comes to maintenance. So we thought that'd be kind of a nice one, go down and meet with some people. So anybody going down to the conference next week, if you're roaming around there, stop by the Ludeca booth, stop by, see me, say hey. If you're so inclined, we'll jump onto a little mini podcast. You don't have a problem with me doing a mini podcast, do you?
No.
Brett, if you're not available, if you're teaching class or something.
I think that'll be fun.
Okay, yeah. We thought we'd do these little offshoots, if you want to call them that. But yeah, other than that, I've been this last week and a half, I've been just absolutely cramming. I'm getting ready to take my my CMRP exam, so I've been doing a lot of studying for that, going through best practices, going through the book of knowledge from SMRP. It occurred to me when I got on there a few days back, I had let my SMRP membership lapse, so that turned into a bit of a process trying to get that renewed, getting my chapters put back up. But all's behind us now, and then I've been trying to help Joe Anderson from Reliability X out as well. We're doing kind of a revamp. I don't know if that's the right word, but update, whatever you want to call it, to some best practices. Because we found a lot of the best practices that are out there, a lot of the books and materials and marketing and blah, blah, blah. It's really focused on why you should use best practices and what they are. But if you read through them, there's not a single best practice in there. So we're trying to kind of write some best practices on whether it be alignment, bearing installation, fan balancing, whatever the case may be. So working on that, and then we've got some road shows coming up. Our next one down in our area is December 9th down in Kansas City. Then they've got one, I believe it's December 14th. They're doing up in Wisconsin, up in Eric Fritz's territory. So we got a couple really good ones coming up. I think it's ridiculously inexpensive. It's like $395 or something to attend one of these for an all day symposium, and you'd be hard pressed to find a better presenter than Joe Anderson. So
good information to get from this.
100%. So I urge anybody who has the wherewithal to do that to attend these things. I think I can't speak for Eric. I don't know what he's capping at. A lot of it's based on, what can the room take. We're capping ours at 50. I'm not going to speak to Eric's. I would assume probably the same, but I don't know. But yeah, just make sure you get on, follow Reliability X on LinkedIn, follow Reliability U on LinkedIn. We'll have all that stuff up there as well. So yeah. Anyway, moving forward, just figured I'd keep everybody, up to date on what was going on in life. But we've spent the last 2-3 episodes spending a lot of time. I don't think it was by design, it just happened, but we spent a lot of time talking about vibration and things related to vibration with motion amplification, balancing, but it's all rooted in vibration analysis,
which with good reason, because it is one of the technologies that's kind of everybody knows. If you got a PDM program, it tends to be that's one of the main things that's there first. But like you said, we can get kind of stuck in that's the only thing we focus on. So we kind of want to branch out. We plan on having some, thermography and oil analysis and people on that are, experts or at least really good at what they do in those fields. So coming up. But today, our topic is going to be alignment.
Alignment, yeah. So I reached out to a friend of mine. He's a proverbial wealth of knowledge when it comes to alignment. Spent the majority of his career working in gas and oil and compression, doing ER82 flatness checks, things like that. So, I mean, he's more than just your, let's make these two lines match up. I mean, the guy's pretty damn smart when it comes to this stuff. He's been referred to as an expert. He's been referred to as an asshole. He's been referred to as an HR's department's worst nightmare. And all of those things are true. But the guy has forgotten more about alignment than most people will ever know. We're very fortunate to get him on. As a matter of fact, it was earlier this week, I believe. My son came down in the living room, or actually it was over the weekend because there was a football game on. And he brings his iPad down and he's like, "Hey, Daddy, I'm talking to your friend." And I'm like, "What the hell are you talking about?" He somehow managed to, I don't know, he just punched her. I still to this day, I'm not an IT guy. I can't figure out how he got it, but he somehow punches his number into his FaceTime on his iPad, calls him, and he's having like a full-blown conversation. And he brings the iPad down. And he's like, "Hey, I'm talking to your friend." And he's like, "Hello?" I'm like, "Who is this?" And he's like, I'm like, "Oh shit," voice very recognizable. I'm like, "All right, got you. How the hell did he get a hold of you?" And he goes, "I don't know, he just called me." So he's like sitting there having a full-blown conversation with my kid. Now, thank God he knows my kid. He's been over to my house a bunch. We've had a cocktail or two in the pool a few times, grilled a lot of meat together. We've hung out, drank a lot of beers in multiple states, all over the place. But anyway, great guy. We're very fortunate to have him on. I know he's busy just like we all are, so I want to give him a big thanks first off for taking the time out of his busy schedule to do this. Anyway, without further ado, let's bring him on. Chris Greene, my buddy. Let's bring on Bubbles. Bubbles? Yeah.
Howdy, guys. Thanks for having me on.
Hey, thanks for coming on, Chris. So how's things down there in Tejas for you?
It's still nice and toasty warm. I will be using the pool this weekend.
Believe it or not, I still got mine open too.
Ours never closes.
Well, yeah. Well, thanks for rubbing that one in. So I told Alex this year because the wife's birthday is November 3rd. And I told her, I said, man, if things keep going the way they're going, we might be able to eke out, a little. She's not a party person, because she hates and people. But, maybe we could, at least have some people over for, and she's like, I don't think we're going to make it. And I'm thinking, that's what, they got up to high 70s today.
Yeah, it's warmer today than.
And I got the pool at 86.
92. We're at 92.
That's brutal. That is brutal.
But is it a dry
Like,
heat where you're at? Because I always hear
keep
that
these
about.
cold.
There you go. That Coors Original Banquet?
Oh, yeah. Fat Boy Specials.
Yeah, all right. Grew up on those.
I haven't seen one of those in a can in a long time. Normally it's the little 12-ounce glass bottles.
We in this house, if we're getting close to less than a case of beer, we're almost out of beer.
Well, 100%. I'm that way with bourbon. Once the bottle hits about halfway down, I got to go to the store. I'm not going to be caught without.
Well, it's coming up on bourbon season. We get down to 50 degrees, I'll be drinking more bourbon.
Bourbon season. I like how bourbon has a season. Every day is a bourbon season.
It's like everybody's like, oh, you have them in the winter. They keep you warm. Like, I have them all year. It's just a thing.
Well,
so
anyway.
I wanted to kind of bring up something that I've been running into a lot. And, I work for a company that sells laser tools. I work for Ludeca. And I get to do a lot of training all over the country. And it seems like there's always these issues that happen in rashes. But if you look back at the cause of the rash, it's always the same thing. And it's everyone's got different expectations of what it means. Okay, we're going to go and do an alignment, whether it's specifications or, what can these guys actually do? What do we expect? And I really feel like we need to spend time reassessing, when you say you want something worked on, when you want something aligned, or if you're the one that's being told to go do it, to all have the same language going. Like if we walk into a plant and they're saying, oh yeah, we got a great reliability program. Here's our list of KPIs of everything we've done to make sure our plant's reliable. And you go out there and not with RDI, not with any sort of vibration sensor, just looking at it. When you see a motor, let's say it's a motor on a conveyor drive, 90-degree gearbox, and the motor's just sitting there going ring. The body of the motor is doing this.
Right.
And then you see the gearbox twisting up and down, and you actually see the conveyor kind of jerking back and forth rhythmically with all this stuff. You're like, all right, there's so many things wrong with this whole scenario. And I know, but we got a great reliability program. Now we're right on top of our alignments, and we're right on top of all this stuff. Like, okay, who's telling you that you're on top of this stuff? Is it your KPIs, or is it the guys who are doing the work saying, no, you're good?
Right.
Well, the KPIs are only as good as the info that's put into them, because some people, they don't collect the right data. The KPIs they're using don't really reflect what their problems actually are sometimes.
Oh, my favorite is when someone writes a KPI, like, I know we can hit this, so let's make that a KPI.
Yeah, that's an EVA.
Yeah.
I actually worked at a plant one time, and this was great because they were getting an ass chewing from upper management because their reactive work order to PM ratio was just ridiculously out of whack, right? And I don't remember what the numbers were, so, I'd be lying if I made something up. But it was something stupid, like, 60% were reactive. Well, in order to get them off their ass, in the CMMS system that they used, they just started writing everything up as a PM. And they're like, see, now we're 99.8%. And I'm like, no, you're not.
Yeah.
You just, it's semantics.
And so like, all right, so that's like a top level view, the guys who's like your plant manager or, someone like that. You get one level below that, you get into your reliability managers. And like, I'll be in a meeting somewhere and that's where we start hitting like, what's the expectations? Because I'll be in the middle of a class and this guy will pop his head and go, hey, just as long as everything's under 2. And then he cruises back out. And I'm like, where the hell did you get this 2 from? Oh yeah, he just wants all of our alignments under 2. And I'm like, I mean, if we're doing dial indicator alignments, yeah, that'd be great. But when we
Right.
start looking at the resolution of a standard laser and stuff like that, and even if we don't change the coupling diameter on some of these systems, it just shows as rise over run per inch. So if you say under 2 for angularity, that thing's going to go to bed hard. Like, I'm passed out. I'm done. I ain't doing it no more.
So there's a certain plant. I won't name it. I'm not going to name names, but there's a certain facility that I do a decent amount with. That they're because they had asked me one time with the tools that we represent and use and blah blah blah. Said, oh, you can add your own tolerances. Yeah, you sure can. Because obviously we have ISO and ANSI built into the tool, but they're like, oh, you can add your own. Yeah. And I got a call and they're like, we can't figure out how to put our own tolerance in this. So I was explaining it to them. They're like, no. How do we put it in at the foot? I'm like, I believe you were the one that coined the phrase, you want to hit your balls with a brass hammer. How do you say that?
I'll say that off camera sometime because it gets pretty vulgar pretty quick and my wife's present.
We don't give a shit. But
she doesn't know why I still have a job actually.
But the point is like we're not aligning at the feet. And we're aligning at the coupler. And I was mentioning this in the intro segment as well. So I've been doing a bunch of work with Joe Anderson here recently at Reliability X, helping them rewrite. I shouldn't use the term rewrite, but update some of the best practices that are out there, because a lot of the best practices they're antiquated. Nobody's touched them in years. Blah blah blah. And back in 1986, that might have been the right way to do things, but we've learned a lot. And I'm not saying the guy that wrote those tolerances was an idiot. I'm not saying that at all. I'm just saying at the time that was probably the best way to do things, but now it isn't. So I've been going through a lot of this stuff with Joe, and one of the things that I stress in my alignment classes is we are aligning at the coupler. We are not aligning the coupler. And there is a huge difference. We're using the coupler as our gauge. Yeah, our gauge. There you go. Our gauge or our benchmark or our
it's
point.
Our pivot point.
Yeah, it's our pivot point, our point of reference, whatever you want to call it. But at the end of the day, if I had a nickel, and chime in on this, if I had a nickel for every time somebody said to me, yeah, well, our coupler, it says right in the manufacturer's specifications, it'll take 50,000 Smiths alignment or 30,000 or whatever the number is. You're not wrong. It will. The bearings won't. The shaft won't. The air gap won't. There's the rest of the asset won't, because how do you know when you've completed a good alignment? And they'll say, well, I got smiley faces or stars or greens or whatever. No. All you know is you hit a tolerance. You don't know that alignment was worth until you extend the mean time between failures.
So that's the end goal, period. Now, all right, I can shed some light on where some of these misnomers have crept in and become like gospel. The 2, everything under 2, blah, blah, blah. And especially at the feet, everything 2 under the feet. So for years and years and years, everyone has preached soft foot. And the standard for soft foot is 2.
2000.
So we say, okay, we need all of our soft foot readings, which are at the feet, to be under 2. And a lot of the plants that I go in and work with, they're like, yeah, but that's also your tolerance for the feet for the move. I'm like, no, the only time the tolerance 2 comes into effect is at the feet for acceptable soft foot. And certain industries actually want it to be 1. Like you get into some of the nuclear parts, they're real touchy about stuff. So 1. So I feel like, well, they keep hearing 2. Oh, well, it's a catch-all. 2 is the catch-all for everything. We'll be fine as long as everything's under 2. And the unfortunate part is, as soon as you shed light on that, and this is where it gets really kind of squiffy in some of my trainings, I will absolutely show someone, all right, here's the 2000 tolerance for soft foot, and we go over that, and we go over what the actual tolerance are, ANSI, ISO, whatever you want to go through, and show them what the tolerances are there for the shaft alignment, and show that there's differentiation. Then all of a sudden, those guys are like, well, that engineer's an idiot now. And I'm like, it's not that he's an idiot. He could be a very, very smart person. but he hasn't actually had to implement these things in real practice. He's just been preached to. He went to college for years and years and years, and they told him all these things. And then he's handed right out of school a reliability job. You can always tell when you walk into the plant, he's the one with the clean shoes, the clean pants, the clean high-vis vest. But he's telling you how things should be in the plant. Like, you haven't been in this plant long enough to tell me what the plant does even.
Yeah, the plant's 80 years old. I mean,
So we just caused a bigger rift. We just caused a bigger rift because we told the technicians what they needed to hear, and they're like, "Well, we're never going to do that because this guy over here says we need to have all this." It's like, so I wrote a paper a long, long time ago. I called it "The Chicken and the Egg," and it's when all these information inputs start colliding, and like, well, who do we trust? I don't know. At this point, screw it. And you get into a plant where you got plant managers saying, we just want everything. We want uptime, we want runtime, we want throughput, whatever it takes to get there. And then you got the guys that are in the field like, well, what do we do to get there? They do as much as they can to try and contribute to that. But at a certain point, they feel like they can't do it right. So why do it at all? And then you get into this ugly, vicious cycle. Well, then fine, we'll just run it to failure. And so it's like, all right, who gave up first? Did management give up on learning the equipment in a way to help their technicians have the right information? Or did the technicians just give up to the point where the management's like, screw it. As long as it runs, it runs. We're making money. What the hell? That gets ugly quick.
I don't want to derail the conversation very far, but I think that comes down to one of the biggest reasons I've seen that failure is we've all heard of planners, we've all heard of schedulers, and it's the plants that, because they're trying to save a buck or they don't have enough manpower or whatever the reason is, they have a planner scheduler. That doesn't work. A planner and a scheduler are two completely different job tasks.
Then you stick a parts person in between them.
Right. And so a planner should be doing the what are we doing, how are we doing it, et cetera, et cetera. And then the scheduler should be doing the who is doing it, when are we doing it.
The logistics for what the planner needs done.
Yeah, and when you try to combine those two, because you're trying to make a job plan, like you alluded to, you're trying to make a job plan, and now you have a scheduler trying to make a job plan. That scheduler doesn't have and it's not that he's not capable, or I should say he or she is not capable of doing it. There's only so many hours in the day, man. They can't do so much. And I think a failure and success is driven from the top down. And I truly believe
it should be yes. It should be yes.
Failure is always driven from the top down, because why do people quit jobs? People don't quit jobs because of how much they're getting paid. Sure, that plays into the big picture, but the ultimate reason people don't quit jobs because they're underpaid. People don't quit jobs because of this and that. They quit jobs because of how they're treated, or how they're viewed in the organization. And a valued member of an organization, if you truly feel valued and you feel like you're heard, you'll work for a little less. Now, I'm not talking $5 an hour, but because you feel like you're making a difference. And
well, part of that goes back to quality of life. If you are happy with your job, the money is what we do it for. But at a certain point, am I contributing? Am I moving this along? Do I get satisfaction out of this?
If you love what you do, you'll never work a day in your life.
I worked in racing for 10 years. Don't tell me that.
There you go. So tell me about those Vipers, baby.
Lots of work. Lots of rich people wanting you to do everything all night so they can do it again tomorrow and break it again.
And I'm sure they're probably the first ones to want it done for free or on the cheap.
Yeah, that is typical. Actually, there's something I also wanted to bring up. When we're talking about expectations and stuff like that for the work being done, the other half of this is the actual equipment. Like, all right, so I don't want to get into Ford versus Chevy, because if you ask me, every single vehicle out there is a piece of crap. So it's just how someone used it that made it become a piece of crap, really. But let's say you have, like I was working with some guys this week, who do large mobile pumping units. So we have a very large engine or a very large electric motor driving a huge pump. It's a full tractor trailer. The whole assembly is an entire tractor trailer. And they're like, yeah, we need to get these really super tight alignments because this is what our coupling can take and blah, blah, blah. And you look
Right.
at it and like, there is no way that this trailer is accepting 3,000 horsepower and 19,000 foot-pounds of torque
And not
and
twisted.
staying stable and not twisting. So my next step actually with that customer is I actually feel like I train their guys to document, yes, they could align it in the shop. While it's sitting exactly where it is, with no one touching it, it is aligned. And then we can track movement. So I said, all right, here, let's try this. Put the sensors on the trailer in a way that when they hook it up to a truck, see how much the carriage moves. Not the motor, not the pump, the actual foundation, which is that trailer. See how much that moves. And they're like, well, okay, what does that get us? I said, well, if nothing else, at first it just gets you out of the blame game of saying, well, here's the expectation of a perfect alignment. You guys perfectly aligned this, right? Yeah, you perfectly aligned it. Okay, then why is it still crapping out the coupling? Is it the guys who did that alignment's fault? Absolutely not. So the other side of the expectations, we have to see what the hardware can take. Now, when you were saying earlier, well, we say these couplings can take this much. It can take 40, 50 thousandths or whatever. I was part of a huge conversation with a large yellow engine manufacturer one time. And
No
they had
names
this
given.
one. No names given. They just happen to own the color yellow. We were discussing this one unit. They have like no adjustment for this one pump that bolts onto the front of a really large engine. It's an auxiliary pump that's driven by the front of the engine, not the flywheel. And it has a little 5-inch coupling, and there's no adjustment. There is no adjustment. So the design phase of it, they said, well, we've read the coupling manufacturer's book, and it says that it can live, their specifications say it can live with this much. And the coupling manufacturer had a representative there while we were going over all this. And they said, no, our coupling can take that for initial startup. We're anticipating that if all the information was put into the alignment correctly, it will thermal growth, torsional load, everything move into a better condition. So yes, purposely misalign it cold, not running, whatever. So that when it arrives to a fully loaded, fully temperature working condition, the coupling is actually moved into a better place. So it isn't flexing the shafts anymore. It's not exerting any force on the bearings. But to say, no, we're just going to continuously run at your tolerances
Right.
for 100% runtime, sorry, can't help you. I mean, the customer, who was the really large yellow engine manufacturer, said, no, we know your coupling can live there because your book said so. And they're trying to explain, no, our coupling can't live there. No, you're wrong. How are we wrong? We made this thing.
Right.
So setting the expectations up front with a firm understanding from everyone of what the actual desired goal is. And this is the dumb thing. All that they needed to do is actually make a little adjustability, like 4 holes that this thing bolts up to. Instead of them being perfect fit for that bolt, leave a little room just to...
give an 1/8 inch on either side.
It actually more like a 1/4 inch, but okay.
Okay, all right, 1/4 inch. And
they needed some room.
I'm glad that you brought all that up because we talk about, what is achievable versus what we strive for. Maybe that's an okay way to say it. I don't know. Because tell me, just based on your experience in the field, how many times have you seen people will go out and do an alignment? And it's like, all right, tolerance, I'm just making up some numbers here. We're looking for 2,000ths offset vertical and horizontal, right? And a 0.5 thousandth per inch of run for angularity. And they get those numbers down to, let's just say for sake of argument, 1.6 and 0.3. Hey, I think I can get it close. Walk away.
We all right. So it comes down to this thing, like what's good for the machine. And if you're trying to absolutely achieve zero, let's say it's an electric drive. Let's say you can get an alignment, man, we can make this better. We can make this better. And you sit there and fiddle with this thing to where you have absolute 0.0 everywhere.
Well, I want to screen out of
that. We'll talk more about that here in a little bit because I did get a call at the beginning of the week. If it's an electric drive, any amount of horsepower to an electric drive. I mean, anything, say 5 horsepower, a bench grinder. Have you ever turned on your
Right.
bench grinder and felt your whole bench kind of torque a little bit just from the
Oh, yeah.
mass spinning up? All right, so
Yeah.
any electric drive, you apply power, it tries to make 100% torque at 0 RPM.
Right.
The old equation, 5 times inrush current. It's going to just try and it wants to go. Okay, great. You just lost 0. You just lost 0. So fiddling for that extra
Right.
bit isn't going to be worth it. And what if it just was enough of a jolt? You did absolute 0, so it pushed it out of alignment.
Yeah.
So all that tight tolerance you just thought you were better than, you actually made it worse.
And
The
I'm
other
glad you
part,
bringing that up. So, and this is a me thing. I personally hate the phrase thermal growth. And here's why. I understand things grow thermally, but they can also shrink thermally.
yep,
They can also
yep,
move, they can also dynamically move for many other reasons than thermal factors.
that's just one of them.
Yeah, torque loading, process factors, head pressure, in current rush. There's a lot of reasons something can move out of alignment. And therefore, I feel like thermal growth, air quotes, kind of pigeonholes you. It's going to grow because of temp. Yeah, it might, but you're missing 75% of the other reasons things move, which is why I always teach dynamic change.
Okay, so thermal growth is the starter drug for getting advanced on your alignments. It's your first step towards, hey, we can do this better.
Right.
It's the very first thing because I come from oil and gas, and luckily most of the stuff I worked on, it's got a complete oil bath inside both the driver and the driven engine and compressor, whatever. So
Right.
thermally, they very evenly expand to each other. So there's a little bit of an offset. It's not much. Sometimes it's like 3 thousandths at the most. Other times you might get into like 5 or 6 thousandths, 7 thousandths, but that's easily accounted for. The rest of the package grows uniformly. Now, when
Right.
you get into food processing, when you get into chemical refineries and stuff like that, that's blown out the window because they do not do it uniformly.
Sure.
And so we have to get them to acknowledge the thermal growth portion first, just that part. And so, like when we're doing a training, I try to build on each concept, builds on the next. And we have to go over thermal growth to get them to think, oh, yeah, these things do change dimensionally. And then after that, we add on to it dynamic change, dynamic measurement, because we do need to acknowledge all that. And like pipe strain, I don't understand why more people are not doing some amount of pipe strain study. It's not hard. We have the technology. Like if you get one of our certain alignment systems, it's very super affordable compared to what you just paid for the alignment system. The dynamic brackets are super affordable to actually accommodate all of this other stuff that we're talking about. But there's been other programs in the past using lasers to do all this dynamic measurement, and it was a little clunky. It was an evolving technology, basically. And we didn't have people in the field with the customers all the time going, no, you're doing this right. No, you're doing this wrong. So it kind of bit everybody. So as soon as we start bringing up dynamic measurements, those who've tried it in the past, sometimes they'll be like, oh, beyond there be monsters. We're not doing that again. And we have to show them newer technology is better at capturing this and how we process it to correct it. We have to take the boogeyman out of the process.
So you guys are more of an expert on this than me. And my fields have crossed over in thermography and vibration and all the other stuff, but I haven't done a ton of alignment, which makes it good because I can ask the layman's question. And that's what I'm going to ask next is for you two, of the things you should do before you start the alignment process, what are like the first couple that you think are the most important? Because there's, as you mentioned, lots of things that can go into it and can change the alignment after it's started up and started going. But like I know about soft foot, and I mean, we teach about soft foot and vibration analysis, and we want people to be aware of it. You should fix that first. But like thermal growth, does that have a big factor in things? How often does that actually play into your alignment? Is there things aside like pipe strain? Some of the more common things, but what would you say like the first couple things for you guys before you start the alignment that you should take care of? Like if you're just giving somebody a quick point of, if you're going to do one, do these couple things first. There's lots of other things that go with it, but what are the first two things that you guys think are probably the most important?
So, number one, I'll answer that question because we still have legal obligations, and I don't want to get my ass in the ringer. Lockout, tag out. I'm just going to throw that one out there to make sure we're covered.
Good call.
Because I am not a OSHA fanboy, all your. Some of OSHA's regulations are stupid.
But we don't want to get fired. We don't want to get.
But we don't want to get fired soon.
Wait, hang on. I'll back it up even a step beyond just it being like a OSHA fanboy thing. This is not a totally attractive package, but I don't want it coming home any uglier. I am married. I don't want her to run off. Right? So I'm going to protect this ugly mug.
We don't need marred during the process.
And I'll stress that to the point of, so I remember I was working, doing some vibration routes. I'm going to take a little bit of a detour and I'll come right back. So I was doing these because this was an OSHA requirement. Because if you go into a confined space, you're required to have a rescue harness on, right? You got to have a, whatever they call it, a rescue tether or whatever.
Manhole watch.
Yeah, manhole watch and the whole thing. So I'm doing these vibration routes at this plant, and I'm going into these air handling units. And in this one air handling unit, it's probably 6 foot high ceiling. You walk down this little gangway. You've been there, okay. Brett. You've been to this plant.
Mention the name, but
won't mention the name, but you know where I'm talking. And you walk in these air handling units on your right hand side. There's these 8 turbofans. They're direct coupled 3,600 RPM turbofans for this AHU. And you walk in there, but since there's only one door, it's a confined space. You got to have a rescue lanyard on. And I told the guy, I'm not wearing a hard hat, safety glasses, badge. I'm taking the neck strap off my data collector, everything. I'm walking into a tunnel that has a massive amount of suction going through it. I'm not getting tangled up in this thing. So at some point, I do think that OSHA regulations inadvertently circumvents common sense. But I will say, for the most part, I got to be careful, but for the most part, they're looking out for the best interest of the worker, for sure.
We're trying to engineer common sense back into it. I wish we didn't call it common sense because it's not so anymore.
It's not common. It's
if
very
we could write a class of common sense, we'd be billionaires tomorrow.
Yeah. But
so actually, the next thing after the lockout tag out, and I can't stress this, any industry, I will say the same thing. You have to do the rectal cranial inversion. You have to pull your head out of your butt and look at what you're about to work on and acknowledge what you're about to do.
Hey, hold on. He's actually filing for a patent right now on his computer for that.
Got it.
Head out of ass.
You got to.
I think that's where
if you're walking around and you're seeing pieces of the coupling, you're seeing, shredded belts hanging off this thing, you're seeing broken off bolts. I'm sorry, you're not there to do an alignment. You have other.
I could probably dumb this down than what you're saying and say, can we do a just common sense visual inspection before we even start the alignment process?
Yeah, 100%.
Let's look and see. Look, listen, hear, feel, whatever. Not taste. We've already decided.
Not taste. But your tongue off the motor.
Use our common sense and look at.
Gotta make it weird, didn't you?
Well, and it's the same thing with balancing. We had a discussion about balancing last time. Let's first make sure that it is balanced, because a lot of people assume that this thing's vibrating. It's a fan. It's probably out of balance. Yeah, very well could be, but it might be something else. So it sounds like what you're saying, the process is, first of all, let's make that first wise choice and say, is this for sure an alignment issue? And then also, I'm here getting ready to do something. I have this thing down. Let's do a visual inspection. Let's see if there's cracked welds, there's bad base, there's pipe strain kind of issues. Lots of different things that can come up. But okay, good point. So head out of rectum.
So with all, yeah, I mean, we have a 5-step procedure that we hand out to every single one of our customers as part of our training. It comes in any of their new tools. Long time ago, I read a book by a guy named John Petrowski, and it's the Shaft Alignment Handbook, and it's what I read before I knew what the hell I was doing, really. And, I'd been around, I'd seen a lot of people doing stuff, and I tried to follow their lead just to be follow them down a dark rabbit hole of wrong. I had some really good mentors, a guy named John Pugh, people like that have shown me the light. Like, no, there is a procedure. And those first two things we just discussed are pretty much how you should start every single alignment. First, are you capable of doing this safely? Secondly, is it even capable of being worked on? And I mean, from there, it's like, defect elimination. Actually, the best thing about a real alignment procedure is if you look at it from a high sky view, the whole thing is defect elimination. You start with the most basic stuff and just fine tune as you go. You're getting rid of softwood. Before you ever break out an electronic tool of any sort, you're doing inspections to get rid of the bonehead things. Because if you're asking a high level exacting type tool, hey, I want you to measure this thing. I didn't take care of anything else first. I just want you to measure this thing. It'll give you some information. But as soon as you try to start making adjustments, it's like, what the hell are you doing, dude? Why did you? No. So one of my favorite terms that I've learned since I've been part of this whole reliability culture discussion thing over the last few years, defect elimination is something we should all strive to do in every aspect of our lives to keep us from kicking the same piece of the same couch in the dark every night.
Yeah,
well, move dumb couch, dummy.
So, and you're right. And I want to use this opportunity to talk about some best practices when it comes to doing alignments, because we always talk best practice, best practice, best practice. And everyone's like, well, you should do this, but they never give a specific best practice. It's kind of the whole adage of, you ask a politician, for example, what's your plan for remedying this? We have great plans. Well, what are those plans? Nobody ever gives you a specific. Are you stapling your nuts?
No. All right. So let's talk about specifics. When you want to, all right. Yes. So a lot of the stuff I worked on in the past, a common way to turn the thing, to measure the coupling, you're going to turn this thing over. Some people would go and put a big old pry bar or whatever in the coupling and just push it around that way.
Right.
Okay, great. If it's me at my size, I just flex that shaft doing it.
Right.
Certain engines that I worked on, they would just go through a little hole with the pry bar and move it one tooth at a time on the flywheel.
Sure.
So the whole time you're seeing this.
Right.
Oh yeah, that looks great for a measurement. So when you go into specifics, like, all right, so how are you going to rotate this thing? A lot of those engines, this is still on my desk to this day, and you can see it's been worn some. This is the right tool to turn those engines over. So you get a nice fluid, even rotation of it without disturbing what you're trying to measure.
Yeah.
So having specifics like that for what you always got to look at what your audience is. What are they doing? And be able to address it in a way like, all right, well, to do that one, maybe you don't want to measure that one as it's rotating. Maybe you want to let that hold still, filter out the background noise, and take independent points as you go around. Sweeping it around looks amazing for really simple stuff. But at a certain point, you need to isolate the event so you're not picking up bad info.
So, go ahead, Brent.
I'm sorry. Chris, for the layman, what do you call that tool? Has that got a name, and is it common?
Yeah, it's a flywheel turning tool. Actually, the part number wore off it. This actually came from the big yellow engine maker.
Okay.
This is a factory tool that they would sell you, specific for 3 different engine families.
Okay.
So, I mean, the stuff is out there. It's just, you got to take that next step, that rectal cranial inversion point. I'm not going to do it the dumb way anymore. Oh, they make something for that? Awesome.
Yeah.
All of a sudden, a lot of your problems start melting away.
I'm glad you brought that up, because I wouldn't say every tool manufacturer, but all of the reputable ones, we'll call it, the ones that are, and I'm not talking those commoditized, you buy out of your tool catalog tools, but all the good alignment tools, they'll have a, whatever they want to call it, a sweep function on them. Here's my issue with sweep, and you can chime in at any time you want. Does it have value? Yes. Are there instances where it works fantastic? Also, yes. But I try to take the subjectivity out of the alignment process. And if you do an individual point reading or multi-point, as we call it, it always works. Sweep sometimes works. And
So
I'm trying to teach somebody how to do this, do it the same every time. I don't want to
yeah.
have to say, yeah, will sweep work here? Well, is there environmental factors? Is there vibration? Is there direct sunlight? You follow me? I want to I want to teach you, because if you do the same thing over and over and over and over, whatever it may be, you're going to get really good at that. Whatever it is.
So my issue, and I'm not gonna talk a lot of smack about sweep or multipoint or whatever. I'm gonna tell
Yeah.
you from my experience what has led me to use one over the other. It's not so much a limitation of the tool, it's a limitation of me. I mean, I'm a heavy guy. So if I'm trying to work on a small piece of equipment and I'm rotating that shaft and I get my body weight involved, I'm going to flex that shaft. And sweep's going to give me weird numbers. There's also a huge applications where we were trying. This is where I learned a lesson, and it kicked my butt. It's nothing wrong with the tool. It's what I was doing wrong. We had a large application. It is like an 8,000 horsepower electric drive to a really large compressor. And to rotate it, you can't.
That's a large application.
You're not going to rotate it. So what we had was a gantry crane in the building. You'd put a peg in the flywheel adapter, and you'd lift with the gantry crane to rotate the flywheel adapter. So you're putting a peg in, you're putting a strap on it, and you're lifting. Well, every measurement we made, no matter what we did with the alignment, kept saying that we were too high. We're too high. We're too high. And we've done come up 115 thousandths on this damn thing. Why does it keep saying we're too high? And it was all about, we didn't understand how it was getting its information. We didn't know enough about how the sweep was actually not helping us. It's because it kept seeing us lift the shaft to rotate that flywheel.
Mm-hmm.
So that's what kicked my butt. 3 hours worth of wasted measurements. Lots of really pissed off people standing around me. It's like, oh, we have this other button. Let's do that. And all of a sudden, that we took 115 thousandths back out of it.
It's a great example.
It is. I've always been a big advocate for, it doesn't matter what tool you buy. And we don't even have to talk about alignments here, just in general. But we will talk about alignment. But it doesn't matter what tool you buy. At the end of the day, it's a tool. That tool should make your life and your job easier. And the tool is only as good as the gray matter between the ears of the guy running. And I go back to the adage over and over and over that a sharp tool doesn't make you a surgeon. And I have a true belief in that, because you can take, now it's not a secret. We're not trying to hide it. We're not trying to be like backhanded. Chris is a technical trainer for Ludeca. Ludeca represents Easy Laser Tools. I'm a sales rep for Ludeca. I represent Easy Laser Tools. Do I think they're the best tool on the market? I do. 1,000%. Because if I didn't, I'd go rep who I thought was best. You would work who you thought was the best. They make a good tool. But at the end of the day, it's a fucking tool. And if you misuse it, you're gonna get shit data. And if you make a $20, $30, $40, $50,000 investment in tools, whatever that number may be, if you don't make the investment, whether it be financial, time, or a combination, to get trained on how to use it, why'd you buy the tool?
Well, you bring up a good point too, because as the layman in this conversation, that's one of the things I kind of wanted to know too. Is there any circumstances where, like, specifically you feel like the laser alignment tools don't quite do what they need to do in, like, maybe a certain type of machine even, where rim and face dial indicator type alignments are the way to go? Do you guys still do these at all for any reason? I know some guys that are like hardcore, hey, that's how I learn, that's what I trust, I like it. Do you feel like there's any place where that needs to be the case?
I just reorganized my office. My dial indicators are still here.
I thought you were having a stroke, so I wasn't real sure what was going on there.
Okay, Now, I'm going to all right. I was a diehard dial indicator guy. We taught a week-long class. I could still teach a week-long class on dial indicators. The thing about dial indicators, yes, you can be as accurate as these lasers for the most part, especially if you buy a higher end. And I'm not saying like Stera versus Mitutoyo or anything like that. If you buy a red face dial indicator, which goes down to 10,000s, yes, you can be hyper accurate with that tool, but you are going to have to manage that situation to the nth degree. If your pencil isn't at a 90 on what you're trying to measure, then all you're doing is seeing a ratio of change. So 5-10 years ago, if you told me, oh man, lasers are better than dial indicators, I'd be like, sure, whatever. But the lasers have, in the last, say, 6-7 years, taken a huge advance forward on how we can use them more effectively. And you have to understand how a laser acquires its information. To measure alignment, all a laser sees is as you rotate it, how much did this thing change on a sensor grid? That's all it sees. And then we extrapolate that from all the dimensions you put into it and however much information you let it have to measure your circle to give you those results. The technology has gotten so good that I will not doubt a quality laser tool versus a dial indicator. Price barrier? Yeah, there's always going to be price. I mean, a good set of Stera gauge is $180. I'd rather use dial indicators than some of the cheaper tools that are $5,000 on the market. I just had to use one of these $5,000 tools with a customer, and we did side-by-side measurements. And even the way that they're shown on the software for that cheaper tool how to take a measurement makes it not repeat. Because it actually says start here, go over here, and then go here. So it actually makes you go anti-rotation to what the machine normally would roll, and it gives you really wild numbers. And that's where I'm going to say, you know what? I'm going to go get my dial indicators. I have faith in that because as long as I'm rotating the same direction and manage myself, I can be accurate. This tool has it the way it's shown. Now, you can cheat that tool. You could actually do your measurement here, and keep going that same direction and take another one here. But the people who market that tool don't show that. Oh, no, we can do this on 180 degrees. You don't have to go all the way around. You only have to do 180 degrees. So the sales pitch for that tool actually makes it not as accurate as that tool could be. So,
Great
answer. If you know how a laser works, you can see that. We could actually help our competitors if we taught them that.
Because you have torsional rotation and backlash on the coupler. And when you bring the thing back, if you imagine two heads pointing at true 12 o'clock, when you preload that, now, and one thing I will say too, and this is a great time for us to jump into best practices. And you always hear, and I've heard it from hundreds of people, you always want to always rotate in the same direction, always rotate in the same direction. Yes, that's true. But also, one thing that I always leave out is also make sure you're applying the torque from the same side of the coupler.
Yep.
Because rotating the same direction is fine, and it should be done. But if you're applying torque from the driven side one time and the driver the next time, you lost your zero. Because you lost your head zero. Because conversely, I would rather you apply clockwise torque from the driver and then counterclockwise torque from the driven. Or it would still be clockwise, depending on which way you're looking at it. But the point is you want to keep the torque in the same direction. And when you lose that, you end up losing zero on the tools. And then people look at the tools and say the tools broke.
No. So there's also the other things that come into play. If you have a pump that's full of a viscous fluid, a heavy viscous fluid, it will actually thrust the shaft into a different location, turning one way versus another. And certain engines, if they have helical cut gears between the camshaft and the crankshaft and idler gears and stuff, turning it one way versus another will actually thrust the entire shaft of that crankshaft. It'll actually thrust it up to 12 thousandths, a different in versus out. And that little bit of change on a laser, depending on how you put your dimensions in, it could have an effect, or at least just make it to where you feel like you're chasing inconsistencies in the measurement.
Right.
Okay.
No,
Well, that's the one thing I bring to this is you guys are the guys that have done this way more than I have. So I can bring the dumb guy questions to this. And what I would want to do is like for the people that are like me that either have very little or maybe even no alignment background that might be watching this, could you like kind of walk through like maybe even some of the definitions? Like you mentioned backlash. Maybe not everybody knows what that is. Let's talk about some of the terms and like some of the things, the simple parts of the alignment process. That like, what are some of the just basic steps? You mentioned, Ludeca has a 5-step, I believe,
yeah.
a little diagram thing you can use. Can you kind of walk through that for a very low level? How do I start an alignment process, and what's just the very low basic parts of it?
So, I mean, we actually start our classes off with this. That's part of setting the expectation. We have to have a procedure. In order to get to the end result the way we want to, we need to make sure we follow the procedure, which is defect elimination the whole way. So, like Adam said, we got to do the lockout tagout. We have to do the visual inspection. We also have to clean everything. We got to make sure we're working in a clean type environment to where inconsistencies can't just walk their way into our feet and stuff like that, to where we're trying to torque something onto a bad surface. After that, we do inspect the feet, the mounting for the machines to make sure if it's on shim, we really want the shim to be a clean, stainless, non-compressible shim that doesn't have 15 layers of anti-corrosive paint, stuff like that. What I work on a lot doesn't even have shims. We have these. This is called a rotochock, and it's an adjustable chock. So this is actually to account for a certain amount of angularity at the feet, just so you don't have to go and cut
That
shims
would
specially.
replace your shims essentially.
Yeah,
Right?
these things are awesome. If they're used correctly, you never buy shims again. They're not
And
cheap, but
I don't
they're
want to keep
really
interrupting,
effective.
but I think while you're going through these points, it's a good point for me to ask the dumb guy questions. Also, you mentioned, the type of shims you should have, but like I've heard so many different versions of how many shims should we have in there? What's the minimum or the maximum amount that we should use? Because everybody has told me different numbers, 3, 5. I've heard tons of different things. What's your opinion?
So our company line, and I'm going to stick with our company line because I believe it's right. It's 3. You can get to any number in 3, even if that means you got to go and have quarter-inch plate cut correctly.
Yeah,
Quarter-inch plate that measures, and I'm always measuring shims as well. I don't care what that number is stamped on there.
so you
That's a
got
guide as to
micrometer.
about what it is. I'm going to measure it with a set of dial calipers and make sure that it really is what I know I'm putting under that foot. After we do that, you eyeball the thing. You eyeball the alignment to the best of your ability. If you can straight edge across that coupling, go for it. Knock your socks out. Go for it. That's just going to give you a better opportunity when you do go and mount the lasers, that they can see the situation better.
Sure.
So we eyeball the alignment. We also manually fix the software. I'm kind of on a little bit of a crusade on this, and some people absolutely want to shoot me in public for this. I don't use dial indicators anymore for checking software, especially if you're doing it one corner at a time. Because if you have energy that's being held by a bent foot in one location, when you go to all the other feet and start loosening them one at a time, that's going to release a certain amount of that energy. So it's going to blow all your numbers higher than they were. So over the years, I've noticed what people have been trying to tell me, and it actually works. Just loosen everything. Let that machine just sit
You're
there.
saying the alignment tool itself is actually adequate to do a software, right?
No. Before the tool has left the box. Before the tool has ever left the box. This is all the stuff you need to do before it's a $5,000 tool, $12,000 tool, $50,000 tool. I don't care. This is the stuff you better do before you start depending on electronics to tell you, you're doing a good job. This is the handle it, man. So yeah, I'm eliminating defects before I get to the fine nut cutting. I'm going to eliminate all the big defects so it can tell me better information. So yeah, I'm going to let that machine just sit there. I'm going to start poking around with either shim or feeler gauge and find gaps, find where there's looseness, and fill that gap. All right, there's 2 reasons for this. 1, we don't want to flex the foot of the machine when we work. But 2, a lot of these plants have been around since dirt was white and Jesus was a baby. Is there a chance that there's fatigue in these bases, in these fixtures?
100%.
Now, if we are going in and absolutely trying to pinpoint exactly where the softwood is in most of these applications, and I'm not saying just oil and gas, I'm saying every industry I've been they all have this problem where the base is actually deflecting as you torque. Now, here's the fun part. If there's an open gap there and we add shim to that open gap, if we torque it correctly, this is a dirty word, what should not happen. It should not deflect. It's going to deflect. The bases are worn out. And the newer bases, since 2010, the price of steel has nearly tripled. So the first thing a lot of these providers of these bases cut down on is the amount of steel or the quality of steel. So that same whole base deflection thing applies to the newest stuff as well. Yeah. So we try to eliminate that defect.
Okay. Yeah.
Then we torque it right.
So I guess what I'm hearing too is you feel like feeler gauges are a good start for the softwood before you throw the alignment heads on the shaft. Feeler gauges right off the bat. Let's do that. Okay, good. Well, and I come from industries where they're aged. These places have been around for years, and bases have crumbled. They've gotten bad. This is talking about like already in-service machines. We want to check for softwood. We want to look at the bases and stuff. But what about if somebody's putting in a brand new machine and they just put a new base in? Like, we can make the assumption that the base is good, but what would you do ahead of time before I even did an alignment to make sure, how do I know the base is good? What test do I do?
All right, well, I'm spoiled. I'm really, really spoiled in that my company lets me have 19 different laser systems in my house. And one of them has a geometric function. So I will, if I have a bare base, nothing is on it, I will absolutely measure that base for flatness and shim it to be flat before I ever bring in my equipment.
Perfect.
So I'm eliminating, hopefully, like a brand new motor coming from a motor shop, it should have plain feet. Same thing with a brand new pump, unless some ding dong dropped it in the warehouse or whatever. But if I can, and I always want to start everything with a certain amount of shim. Like Caterpillar, a lot of their literature back in the day said, I said the name of it, sorry.
You mean the big yellow guys? A lot of their literature
back in the day, big yellow guys. They actually stipulated in their old A&I guides, if you're fabricating a base for this, start with 125 thousandths of adjustment under the engine at fabrication level. So you have room to come down if you need to.
Perfect. Yeah.
And so I will always measure a base for flatness first, shim it to be flat. So when I bring in a new pump or a new motor or a new engine, whatever, honestly, I should have a flat, no softwood to begin with. It's a little bit of work up front to save a ton of work later.
Perfect. No, that's a great answer because that's what I'm looking for. You guys, you know what you're doing. It's obvious you do, and I've been sitting here quiet for a lot.
I make it up as I go.
But that's why I'm here too. Is like if he doesn't know, I know. If I know, he doesn't know. It's kind of back and forth. It kind of works out that way. But it happens to be.
I don't know shit.
He is really good at this alignment stuff, and he's tried to show me before. And I wouldn't say I'm a slow learner, but like I just don't do it that often. So
he's a fucking
the questions I ask.
He's a vibe guy. He's a vibe guy.
He's a vibe guy.
Exactly. Why do you guys expect?
You know what? You gave up a certain amount of your common sense to be a high level vibe guy. That's what it is. And on the totem of reliability, alignment's way down there. You know what? You're smarter than us. Just keep going with your vibe stuff. We'll handle the low hanging fruit for you.
So when I mention layman, I'm saying Brett. In Brett terms, this dumb question. What? But no, that's good because that's what people want to know that aren't that good at this stuff. Which I am definitely not that guy. I've done a handful of alignments. A few of them I've watched him do, and I'm like, how do you do this? I'm in awe because I'm like, you just know how to do this. And he showed me, and I'm like. Okay, if you let me loose, I learned a few things from him, but I don't know. It'd take me a while. But you guys have been doing this, and that's what I want to get is for the people that might be watching this podcast, if there's anybody watching.
There's nobody watching.
If there is, they might be like me and be like, I don't know a ton of this stuff, and the terms you guys are using, like, okay, what do you mean? But that's what I kind of wanted to get to is for the layman guy, if I just bought a tool, any tool, alignment tool or dial indicators, whatever, what's the most important thing if I've got only 5 minutes with this guy to say, use this properly? What do I tell him? And that's what I'm asking. And you've already answered some of it. Is there anything else?
So I mean, Adam said it earlier. The tool's only as good as the gray matter using it. And so, like, after we've eliminated the defective soft foot, we need to actually go in there and torque this thing right. And Ugga-Duggas don't cut it. If you're telling me you're using an impact to torque stuff and we're going to do an alignment together, I'm going to get my truck and I'm going to leave. I don't care how far I drove. I'm not doing that alignment with you. We're going to torque these things properly because we're trying to get to a known clamping force consistently. Otherwise, every time we try to go back and measure something, it's going to give us different numbers. And so,
that brings up the next dumb guy question. Let me ask this now while we're on that topic. Is there a source that you guys use for torque specs that is a pretty good, like, just common place to go to for any machine?
Okay, so general equipment, Fastenal. They will hand you a laminated sheet, and it's just basic. It's basic industry torque. It's not specific to anybody. Now, I do work on a lot of specialized equipment, and they will always freely publish and hand out a torque spec for their equipment. Okay. And then, like, when I go and give a training, I give people 5 gigs worth of manuals for free. I pirate the shit out of that stuff. And because if they do all that stuff right, it's actually going to make my tool look better.
Awesome. That's good.
Torque specs should be freely given at every point.
Awesome. That's perfect.
Well, and I'm glad you brought that up because all this information certain things like training's a valuable commodity and it's charged for. But a lot of this information that should just be freely sourced, I've found out is not, which was, shameless plug for us, the reason that Brett and I wanted to start doing this exact podcast and the training.
Get the knowledge out.
We want to get the knowledge out there. We just want everyone to be better. And it's why we want to bring people like you on, that can share this information and not be the whole high and mighty, I'm better than everyone attitude. I mean,
no, and you guys have had great answers for this because, like I said, I'm the guy that I'm asking the questions because legit, I'm not asking to set you up to do something. I'm
trying to fart you.
I want to learn. I'm sitting here trying to learn.
Hang on one second. You guys keep talking. I'm going to grab something to show you guys. Keep going for it.
Perfect. Okay.
He just disappeared. Did you see
that? We've never been in this situation.
My Lord. We don't know what we're doing.
What do I do with my hands? Oh, there he is.
Oh, he's back. Thank God. What you got, bud?
All right.
So yellow.
Every product I've ever worked on has one of these somewhere. Okay. Manuals upon. I mean, this is a 3600 master mechanic class. This is a 1 week class I took, and this is the bad thing about having books like this is people will have a book, the one book, and they will use that to encompass their entire working life.
Yeah,
I know that this book, half of it is outdated. The reason I keep this book is the other half that hasn't been updated still applies. So I always tell someone, when you get your specifications, look at the published date. Look at the version of it. And if that's what you need to get through tonight, 3 a.m. specs is what I call it. Man, we got to get this thing going right now. It's 3 a.m. We got to get it going. This book, I'll use it for 3 a.m. every time. But then after I get done with that job, I probably need to go back and do a little research to see if there's any updates. And maybe I go back and correct something better. So manuals themselves are living documents. Every machine I worked on, I know since I left the field, has been updated. And I go onto their websites and I download those new manuals and I update the stuff. I never delete the old ones because they have a lot of specifications that we still need. And the new manuals are actually cutting some of that stuff. Like there's certain little linkages and armatures, and you have to measure a certain angle for this and a certain length for that. Well, they cut that out for some reason in the newer manuals. I don't know why, but I still keep that information in case I run into it. So there's a whole bookshelf down over here. My office just got moved, so I'm still getting used to where everything is. There's probably 20 different manuals for different engines, compressors, cars, all kinds of crap. It's good to know your information, but it's also good not to memorize it. Do not memorize specifications. Know where to find specifications.
That's a good point.
So you're
It
not a
is.
snapshot of 1986.
That's the same thing for electricians. I mean, to pass the journeyman exam, you have to be familiar with the code book. The code book changes all the time. And that's the same thing with our industry. There's things that change all the time. So don't
I was
get
looking for my
familiar
ugly
with
book.
the 1986 ugly book. Yeah, it probably doesn't apply today. So maybe get the most recent. But it's a good point because, things change, equipment changes. And plus, there's a lot of machines that were designed and they give you specs saying, if you run it in this environment, in this load, this temperature, whatever, it's designed to do this. But we put it in and we don't run it in that situation. So we all have to
Exactly.
be able to, as maintenance people, be able to go on the fly and say, you know what, this was not exactly designed to work in this environment. How do we make this? Because we can't expect it. It's a dumb thing to think that this thing was designed to work in this environment and we're putting in a different one to say, well, it should be good. No, it's everything goes out the window.
That was the key to my success for where I was working. Is I learned we were installing this equipment all over the place. We did the exact same thing every time, expecting the exact same results.
Yeah.
And it didn't. All right. And they'd be like, this one's a bad one or whatever. No, we did not do the adjustments for, all right, we're running this quality of fuel at this temperature, at this altitude. If you change those things, it's going to run different. And
exactly.
Every piece of equipment I've ever worked on always has at the back a kind of a troubleshooting or a tuning key. It says, all right, if it's doing this, look at your gas analysis or look at your input voltage stability and stuff like that. So, being able to make those setting changes to get the best, basically, a performance and runtime out of something, it's imperative. Yeah. We can't just say, all right, well, turn it 3 times to the right and it'll work every time.
Yeah.
Which is why I've always been a huge opponent of using an OEM for thermal growth. Because the OEM will tell you, account for this much, blah, blah. Yeah, do you have any, they don't know. Is this piece of equipment being installed, in August in Houston or February in Juneau?
Yeah.
So we actually had a case.
There's a difference.
We installed a whole bunch of engines here in the Fort Worth area. And here we have moderate summers. We don't have hotter than hell. We just have hot. Well, then when I got done here, we went down and installed a whole bunch of them down by the border where it's 117 during the day.
Right.
And you think, well, okay, when the sun goes down, it'll cool off. Nope. The rock absorbs all that heat and just blasts it back at you. So it's just hot for hot's sake. What we learned there is we had to lower our engines just a little bit more because of the extra growth. When we went back and looked at everything, there was more growth than advertised. My next assignment was to go install the exact same type of equipment up on a mountaintop in Pennsylvania. It was negative 30. Exact same type of package. Everything was the exact same. What we learned there, it gets real winter in Pennsylvania, but they also have summer. So basically, every piece of our equipment there should have been aligned 2 times every year. You do one alignment to get through spring and summer, and then about the time fall, like this time, we would actually have to go and raise some of this equipment because it's going to lose some of its thermal growth. And it's a dynamic change. It's exactly what you called it. We needed to account for the new dynamic change.
Right. So, sticking on the best practice side of things, like we were talking about using the alignment system to measure softfoot. Not using it to do the initial, because you hit the nail right on the head. You're using feeler gauges or shims or whatever, right, to fill those gaps initially. So I've always been a big advocate for to fully understand why we're doing something or why you should do something. We need to understand why it is we're doing that. What are the pitfalls or what are the, whatever. So correct me along the way. My reasoning for not using the alignment tool, whatever brand it may be, to do your checks is you've got your heads mounted cross coupler on the shaft. You are more than likely coupled. I'm not going to say always, but more than likely you're coupled. Well, when you start to have vertical deflection on the movable because of softfoot reasons, that thing's coupled up and it's going to pull the stationary up and down with you, which is going to lower, I guess, might be the best way to say it, is going to lower the amount of offset that you have. Now, if you take that exact same piece of equipment with the exact same amount of soft foot, blah, 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 take the coupler out of it, you're going to get different readings.
So
Would you
we
not
actually
agree with
teach pretty
that?
heavily on that. To an extent, it really depends on the type of equipment, what kind of bearings. Well, there's so many variables in there.
Sure.
For a fact, I know that if we try to use the laser to do a soft foot check, there is soft foot in a quality laser. It has to be there. You ain't selling one if you don't have it. So
exactly.
We have to understand how to use it correctly. We should have fixed all the actual real significant soft foot before the laser ever came out of the box.
True.
But then after we get our alignment under control and normal threshold, because we're a bunch of dorks, we read manufacturers' stuff and we realize, when this thing's about 15 thousandths or less in a bind, when the alignment is better than 15 thousandths, especially for offsets, that coupling should be relaxed. It shouldn't have any real tension on it. So then what we're looking for is every time we loosen a bolt based off the torque we're using, the dimensions we put in that laser, how much did this shaft deflect up and down in correlation to that bolt being loosened and tightened? And that's telling us whether or not we have, in reality, if we did this right, residual soft foot. And the main importance of this is we need to document. We need to document that we actually did this alignment to a piece of equipment that was worthy of being aligned. And if you didn't deal with the soft foot, you just aligned it, and you're going to fight it. Because as soon as you get it right where you want it, everything's good, you start tightening bolts, and the green, the stars start going away, and it goes yellow and red. Holy crap, where's this thing going? Yeah, because you're deflecting the machine, ding-dong. So the soft foot function of a quality laser tool is to prove that the technician absolutely does not have any soft foot in this machine that he's aligning for you. It's the best thing about it is you can do some really cool troubleshooting with it, but if you did your job right, that problem wouldn't be there, and it'd just be documenting. This thing has no soft foot, and the machine is alignable. Not wasting your time.
Because if it isn't documented, it never happened.
Right.
And that's true with vibration. That's true with alignment. That's true with anything, right?
Right. Yeah.
Because everybody's it is. It's 100% about the report. And anymore, if you don't have some kind of step-by-step time stamp, date stamped, I did this, prove to me you did it. Chicken scratching complete on a work order with your signature doesn't cut the mustard anymore. You got to make sure.
We actually ran into this with dial indicator days and stuff like that. We'd be doing a software check on something, and let's say I'm the one recording, someone else is there crammed under the machine doing the loosening and tightening. So they loosen it, and I say, all right, what's the number? If I heard this back, I knew we were in trouble. What's it need to be? If I heard, what's it need to be? And I tell them 2, they're going to call out a different number. They're going to go 1.8.
Yeah,
if I tell them
it's definitely less than 2 then.
Yeah. So, the whole documentation process should be a technician's best friend to prove that if this thing does go to see Jesus early on its own, it's not his fault. He did the best job he could. No one sets out to do a bad job.
No.
But if they record the soft results, I know. So, but in reality, if we have this fully documented, what they did to get the job done, what the final results were, there was no soft foot in it. We've accounted for thermal expansion. We've accounted for dynamic loads, pushing this thing off to the side because someone didn't put an expansion loop on a piece of pipe. It should say, if this thing has a failure, let's do a real failure analysis. This is some of the data that we can use to kind of help us with our failure analysis. And maybe just get that tech out of the blame game.
So we've been talking about soft foot for a little bit. And as the vibe guy, one of the things I like to talk about in class is what the effects of soft foot can be, like as far as how it's detrimental to the equipment itself. So if I have soft foot and I don't correct for it, what happens to the machine? And some people are like, oh, it's probably nothing. Not much. It's probably not that big of a deal. Yeah, no, I agree with you. My hands go in the air as well. But one of the things I noticed, I was working for a company a long time ago, and I was doing some work at a coal-fired power plant, and I was doing motor circuit analysis, and I'm like, man, you guys have a ton of these old motors that like very old motors. And he's like, oh yeah, they've been in here since like the 1950s or something like that. And he's like, oh, yeah, they were so heavy built back then. And we were talking about, like, because I said, man, you still have a lot of them. He's like, yeah, we've only replaced a few. They don't build them like they used to. Point being is talking to this guy and thinking about softfoot. He's like, the motors that came in this facility when they installed it were so heavy built, so cast, such thick, heavy duty things. He's like, when we replace a 50 horsepower motor now, uh, we crane the one out because it's so heavy. The new one we can wheel in on a cart because it's so light. They're making it out of cheaper materials. So the point I make in my classes is, that soft foot years ago with those really heavy duty machines might have been not as big of a deal as it is now, purely because if you think about a lighter construction of a stator and like the outside of the motor, if I do have soft foot and I don't correct for it and I soften that, I tighten that down, I can warp the frame of that much easier than I could have years ago. And now, as Vive guys, we can see this, 7,200 CPM peak that shows up in the spectrum from that warping of that outer, shell of that motor. And I feel like, I don't know if you guys have noticed it, but like the older motors were built so heavy and so thick and built to last, it was probably less of a deal than it is now. But I feel like because they're built cheaper, you can warp it much easier.
Kind of. There's two aspects to that, and I run into this whether it's the motors, whether it's like engines. Now we have emissions equipment on these engines. Oh man, we never had problems with these engines till they started having emissions equipment hanging off it. These motors were fine until we started making them with all these electronic controls and VFDs. They didn't have the instrumentation to know it was a problem back then. Think about your vibration analyzer from, say, 25 years ago, when I would have known nothing about vibration, to compare to what you can walk around and do with basically a small tablet-sized device now. Yeah. So our way of measuring this has multiplied exponentially. Yes, the older ones, they were so heavy, and the air gaps were like huge. I worked on Kato generators from the 60s. One that I bought a generator one time, a generator in from 1961. It was from the original Yankee Stadium. When they tore it down, I got the generator in out of that and put it behind a Waukesha engine. And like when you went in to set the air gap on the exciter ring on that thing, you had a mile of adjustment. Whereas a newer one, man, you got to have it like within 25 thousandths. It's got to be just right. And so the newer equipment, it is flimsier, it is lighter. The winding itself is thinner. It might have just as many turns in it, but it's going to be lower gauge wire. Sure, So we're seeing two things happen. The material's getting crappier, but our ways of measuring are getting better. So we're actually able to quantify these things much better than we ever did.
Awesome. Good point. Yeah. Like that. Well, no, I was just going to say not having talked to you before, this has been a pleasure because I've learned a lot from you two just this evening. So it's been great having you on here. It's, the amount of information we've covered it's kind of in depth, but luckily I've been the layman guy to ask the right questions, hopefully. But no, we appreciate you being on here and stuff. Well, so
next time I come up there, I'm bringing a thumb drive with all this crap that's stuffed in my head. You'll see where I got it from. Well, the worst thing about me is I will read anything you put in front of me, and then I try to apply it.
So you're going to bring a thumb drive. You're also bringing meat, right? Is that what I heard?
Lots of taco meat.
Lots of taco meat. And are you also going to bring a propane scale with you just so we can finally put this to bed?
I've got one right here.
Oh gosh!
There's one on the table behind me. Actually, it's not a propane scale, but it's a
okay.
I weigh my internal parts for my rotary engines.
Talking about
so, just so everyone's on the same page on this, we're going to go off a deep path on this one. So last time or time before Chris was up, I don't remember. We're sitting out. We're going to go grill out back at my house. And I went out and I'm like, I think the propane's probably getting low on that.
Yeah.
So Chris went over, gave it the old shake. And he goes, nah, there's still some gas in there. So my neighbor was over. Now, mind you, he's an oxygen delivery guy.
Yeah.
So you would think he'd know a little bit about gas. And he's like, what are you doing? And Chris is like, oh, I'm just checking. He's like, you can't tell if there's gas in there. And this turned into like this month-long argument about how you can't tell if a propane tank is empty or full based on weight. And I'm like, that's how they fill your propane tanks, man. It's a 20-pound propane tank because there's 20 pounds of gas in it. He's like, you can't tell. So this, and even both of his sons were even like telling him, Dad, you're an idiot. And he just would not. But anyway, so the propane thing, it's a long-standing tradition. But
it's one of those things that you have to end the conversation with, I can explain it to you. I can't understand it for you.
Yeah, 100%.
That's training in general. But
yeah.
Lead a horse to water, can't make him drink kind of thing. Yeah.
Yep.
Yeah, we say we can't shoot it by the bank because it won't drink.
So, anyway, Chris, is there I think Brett and I normally like to ask all our guests a couple questions before we get off.
All right.
The one I'm going to ask is, and well, just kind of like a brief overview. So, Chris Greene graduates high school. Where does Chris Greene go with his life, and how did you get to where you are now?
Dumb luck, lots of alcohol, and stupidity.
All right.
I fumbled around doing different things. I did network installation for a couple of years. I actually did 1 year of advertising sales in Chicago. Then I got sick of Chicago. It turns out I wasn't sick of Chicago. I was sick of the girl I was living with. Moved back to Texas and started working on race cars.
Okay.
So,
awesome.
10 years of professional race car mechanic, and realized I was not making any money. I was following rich guys around trying to make money. I started with the Viper series and the Speed GT Challenge back in 99, 2000. So lots of Dodge Viper stuff. From there, I went into Formula cars. I built probably 60 spec Miatas and turbo spec Miatas. Went from that into Porsche Cup series. Just high-level prostitution.
Is it all pavement stuff, or did you do any dirt work?
I've been to dirt races. They're a good time. They're awesome to watch how these guys can hook up a car and make it do a wheelie down straight on dirt. But that's a different life.
Okay, yeah. Okay, well, that leads in also to my next question, which is I like to ask people, so what got you into this? So for me, like a certain tool I picked up, like an infrared camera, it got me into this, and I'm like, I love this stuff. This is what I'm going to do. So for you, what was the thing that kind of got you into this predictive world that we're in?
Actually, it was by accident. I learned that by doing certain things with the equipment I was having to work on, there were certain things we could do to make them better. It actually meant like looking at that manual and tuning it for the specific application that it was doing and documenting it. That's it. The documentation is what moved me forward. And every step I learned after that, I documented that. And I could see a progression of what I had been doing and where we were going. And that led me to picking up the other technologies to keep doing better. It is purely because I know a lot of guys who are working in an oil field right now that are older than me, doing the same job I did. And they're going to be there for a while because they keep slogging along doing exactly the same thing without looking for that next step forward. And I tell everyone, if you come to my class, I'm going to tell you two things. Never, ever negotiate your next job on dollars per hour. Dollars per hour, they got your ass. You're a whore. You are there until 5 o'clock. You do your 8 and run for the gate. So that doesn't move your life forward. You're still renting an apartment. You're still driving a piece of crap car. I tell everyone the next time you sit down for a good job negotiation, you better talk dollars per year, because dollars per year, it says that I'm building a career here. And then the next thing I tell them, don't worry about your paycheck right now. whatever your paycheck is that's coming next, you've already spent that. You know exactly who you owe that to, what you're going to buy next. You know where that money's going. What you need to be worried about is the paycheck 5 years from now. That paycheck 5 years from now is the one you need to make every move possible to make that bigger, whatever it takes, because that's what buys you quality of life. So that's
Absolutely
how I approach all this crap.
So not only are you a alignment expert, you're also a life coach.
So don't do what I did, all right? Don't follow race cars.
kind of a don't.
I mean, when you start ending up with goofy stuff like this on your desk, which is a water pump fitting to do an electric water pump on a rotary engine. This is super dork right here. So when you go that hallway, you done messed up.
Yeah.
Well, and you know, Super Dork's coming full circle, because the last time Chris and I got together, he didn't even come up here. We got together somewhere. I can't even remember where it was. We were doing a training class somewhere. Oh, it was down at Lake of the Ozarks. It's when we did that training class down there back in May, I think it was. Yeah, because it was your anniversary weekend. Chris shows up with a bunch of 3D printed like octopus and like sharks and stuff to give to my kids to put in the pool. And it's like, he loves 3D printing and my kids love Chris's shit. So.
Oh, dragon?
Yeah. And then.
Is that origami?
Back to you.
Are you into Game of Thrones?
Super dork stuff. Oh, wait, here we go.
Well, I understand if you're into dork stuff, Game of Thrones, that's
is that a wankle?
No, that's
a wankle engine, dude. Isn't it?
Yep. Yeah. That's what a rotary engine looks like on the inside.
That's cool.
That's why my son's name is Felix.
I thought it was Iron Man's chest thing.
Maybe, I mean, it could be Iron Man's chest thing. But
okay.
And if anybody listening would love to learn more about alignment, I'm going to take this opportunity to do a small shameless plug here with Chris and myself, because God, we have fun. May 12th and 13th, we're going to be in Donaldson, Iowa, teaching a public class. You can go on the Ludeca website to sign up for it. We're going to be doing a golf tournament the night of the 12th as well. I hear you've been doing some golf practice there, have you, Chris?
I've been trying to learn how to swing a golf club without looking like I'm having a seizure.
All right. So how's that going for you?
I drink really well.
All right. Good enough. So Chris and I are going to be partners. I'm just letting everybody know now. And anybody else who would like to join us for this, it's going to be fun. We're going to get together. We're going to have a 2-day alignment class. We're going to talk about geometric specs. We're going to talk about thermal, I hate the term, thermal growth. But we're going to talk about, dynamic measurements.
Dynamic change. How about that?
Dynamic change. I love it. Going to go through some just equipment basics and just how to do a good quality alignment and make sure you can go back to work and give it your all and, be the best you can be at what you do. But we would definitely love to have anybody listening come out and join us. But yeah, Donaldson, Iowa, it's in the middle of nowhere, man. But it's I was traveling for work and I found this place and I'm like, they got a lodge, a bar, a convention center, and a golf course.
That's all you need. Right?
What else do you need, man?
What else do you need?
And Casey's Pizza delivers. So we get some jalapeno popper pizza delivered right to the place.
Casey's, by the way, yeah. We'll take a sponsor.
Yeah, anyway. If Casey's wants to throw some cash away. But anyway,
sounds good. Chris, let's do it.
Anything else you want to close out with, or you think you covered the basics?
I think we covered a lot.
We covered
it everywhere, but
as usual, every time I get together with you, I picked up a few things and I learned some stuff.
Yeah, for sure. Yeah.
Brett's sitting here.
Well,
he's actually writing down. Brett's got a pen. He's writing down a notebook. He's like, I already knew all that.
I've got so much notes on this stuff right now. I've learned so much.
He's going to fact check everything.
No, It was good talking to you. 'Cause like I said, you and I don't know that have ever met, but I did learn quite a bit from this thing. It was fun. It was a lot of fun having you on, and uh, alignment is obviously a pretty big deal. It's one of the things, for me, like going to various different plants and figuring out what they have wrong. I can usually boil it down to like three things, and it's either the base issues where they don't have the right bases that their equipment's on, alignment, or imbalance. Bearings, of course, is a big deal, but I typically see a lot of things right up front where that's the issue. We need to get this alignment, base issues, pipe strain, all this stuff, which kind of works everything we're talking about together. And if you don't get that straight, you've got some problems you're going to have to deal with for quite a while. And I think this is
all these technologies support each other.
They do. Use all the tools in your tool bag because we have them. We might as well use them.
Yeah.
CYA.
Yeah, exactly.
And when you look at a CMMS system, when something fails and the planner, the scheduler, the manager, whoever goes back, what's the first thing they look is they go back through CMMS work order history. Who's the last guy to touch it?
Yeah.
You're the one that broke
I hate
it.
that.
It's like, yeah, let's get out of this blame game mentality and let's just fix the problem. It's because I'm not going to say that that's never the case, but a lot of times it's an underlying issue that nobody ever addressed the underlying issue. But all that being said, Chris, man, I really appreciate it. I hope, we will be getting together soon, very soon, sooner than later, I hope. My plan is I've already got it on my calendar. I'm going to be coming to Fort Worth for a crawfish boil next year.
Yeah.
Come on, bring everyone with you.
Me and Brent might make a trip down there, actually.
Come on with it.
Awesome.
I hear
if it's not crawfish season, we'll barbecue.
Yeah, you might have a drink or two when we get there, right?
We're not going to count.
All right. If Sherry will allow us to come, that is. Ask her. Ask permission.
Make fun of us. Yeah. Come on with it.
Well, anyway, dude, Bubbles, appreciate you, man. Thanks for taking the time tonight. It means a lot. We'll talk very soon, all right, man?
Thanks, Chris.
Sounds good. Thanks, guys.
All right. Take care, man.
Later. Bye.